Good morning, everybody. Today we discuss quicksort technique. This quicksort technique is divide and conquer type technique. Divide and conquer type technique means divide and conquer type technique means this quicksort algorithm is based on divide and conquer rule. Divide and conquer. What do you mean by divide? Divide means the given whole array is divided into the number of small problems. Divide the large problems into the small problems, and conquer means to solve. Once the small problem is divided in, once the large problem is divided into the small problems, again you have to solve the solve sub problems. So this is called as the divide and conquer technique. This quicksort is also called as partition exchange sort. This is the another name of the quicksort technique, partition exchange sort. Suppose the array contains all these elements. Now we have to sort this given array using the quicksort method. As it is based on the rules of divide and conquer, this largest element of the array divide into the small subproblems. Here, this quicksort actually consists of the three different sorting techniques. The first one is, it is the elements less than pivot element. Then second one is pivot element, and third one is elements greater than pivot element. So these are the subparts. These are the subparts of the given array. This whole array is divided into the three different parts: the elements less than pivot element, then pivot element, and third one is elements greater than pivot element. Means this given list is divided into the three parts: less than pivot, then pivot, and greater than pivot. What do you mean by the pivot element? Pivot element means the specified value, or the pivot element means you have to start from the first element. This first element actually, in the first pass, the first element gets the final position in the list. So in this example, 44 is the pivot element, the first element. Now, in the first pass, first of all, you have to start from right to left, scan whole list from right to left, comparing 44 with each element, and stop the comparison when you get the smaller element than the pivot element. Smaller element or pivot element is 44. You stop the comparison when you get the element less than 44. So start the comparison. 66, it is greater than 44. 88, again greater. 22, yes, it is small. So you exchange the both positions, 22 and 44. So 22 is here, then 33, remaining elements as it is, and just exchange the pivot element with this smallest element here, 44. This is our pivot element, then 88, and then 66. Now at the second step, you go from left to right and stop the scanning when you get the larger value than the pivot element, than the 44. Start. 22, small. 33, small. 11, again small. 55, yes, it is greater than the 44. So now you exchange. these both values 22, 33, 11, here 44. The remaining elements skip as it is 60, 99, and here 55, then 88, and then 66. Our pivot element is 44. Now at the next step, again you go from right to left, compare 47 with each element and stop the comparison when you get the element less than 44. So we start from the last 66. No, it is greater. You have to stop the comparison when you get the smaller element. 88, no. 55, no. 99, no. Again 60, no. 40, yes. 40 is less than the 44. So here you just exchange both the values. So 22, 33, 11, here 40, 77, 90, here 44, 60, 99, 55, 88, and then 66. Okay. Now, you go from again left to right. Scan the list, compare each element with 44 and stop the comparison when you get the element larger than 44. So, less, again less, and yes, here 77 is larger. So exchange both the positions. This is left to right. So 22, 33, 11, 40, then here 44, 90, here 77, 60, 99, 55, 88, and then 66. Okay, so this is your pivot element. Now, if you carefully observe, then you notice that all the elements before 44 are the smaller elements. See here, 22, 33, 11, 40, all are the less element or smaller element than the 44. And at right hand side, all the elements are greater than the 44. Hence, you get the third part, that is here sublist 2, and this is your pivot element. Actually, I told you that this Quicksort algorithm has the main three parts. The first is the element less than the pivot element, and the elements greater than the pivot element. Less than element, then second part pivot element, then third part all the elements greater than the pivot elements. So now here at the end of this pass 1, 44 gets the final position in the sorted array. Now the whole problem, the large problem is divided into the two sub-problems, sublist 1 and sublist 2. Now, once the problem is divided, then you conquer, then you solve the each sub-problem. So, first of all, we solve the first list. Okay, so 22, 33, 11, and then 40. The first element is 22. And at the end of this pass, the 22 element has its final position in the sorted list. So you start from first step right to left and stop at the elements smaller than 22. So 40 is greater element, 11 is a smaller element. Now you exchange both the 11 and 22. So 11, then this is 33, 22, and then 40. Now at the next step, you start from left to right and stop when you get the larger element than the 22. So 11 is less, 33 or 22 is the pivot element, 33 is the greater element than 22. So you just exchange both values, 11, here 22, here 33, and then 40. Now you observe that all the elements in the sub problem 1, sublist 1 are arranged in a ascending order 11, 22, 33, and then 40. Okay, now you do the same process for the sublist 2. Okay, so this side of this board, and we do it for the second subproblem. Okay. So the second subproblem means 90, then 77, 60, 90, 55, 88, and then 66. Okay, this is the second sublist. So here, instead of this place, just I sort the element here. So first is the 90. So 90 is the pivot element. So you go from first right to left. So right to left, and stop the comparison when you get the less element than the 90. So it is a 66. So now you exchange here 66, then 77, 60, 90, then 55, 88, and here 90. Our pivot element is 90. Now you start from left to right and stop the comparison when you get the larger element than the 90. So 66, 77, 60, 90, no. There is just 1 minute. Here I did one mistake. This is not a 90, this is a 99, 60, and then 99. So our pivot element is 90. And now we start from left to right and we stop the comparison when we get the element larger than the 90. So this is less, this is less, this is also less, but 99 is greater than the 90. So exchange the both values. So 66, 77, 60, then 90, then 55, 88, and then 99. This is a pivot element. If you now, or if 90, okay. Now you go from right to left. Right to left. Scan the whole list and stop the comparison when you get the smaller element than 90. So which is the smaller element? Here 88. So again exchange. So 66, 77, 60, here 88, 55, 90, and then 99. And if you carefully observe, then you notice that all the elements left of the 90 are less. See, 66, 77, 60, 88, 55, all the elements are less, means once again you get the sublist 1, and this is your pivot element, and this is your the element which is greater than the pivot, that is the sublist 1. But in the sublist 2, you have only one element, so there is no requirement to sort the element as it is a single element. Once again, you sort this list 66 up to 55. So just again, the problem is divided into the two parts. And now I conquer, I solve the first sublist. So first sublist is 66. Just 1 minute. First sublist is 66. Then second is 77. Then 60. Then 88. Then 55. Okay. So this is the again small subproblem, and now you have to conquer this subproblem again. You have to solve this problem again to get the sorted list. Okay, so our pivot element is 66. You start from right to left. Scan the whole list and stop the comparison when you get the smaller element. The smaller element is 55. So exchange the elements 55, 77, 60, 80, and then 66. 66 is the pivot element. Now you go from left to right. Stop the comparison when you get the element greater than 66. This is less element, this is greater element. Again you exchange the positions 55, here 66, then 60, then 80, and then 77. Our pivot element is 66. Again, from right to left, you compare each element and stop the comparison when you get the element less than 66. And here, this is greater, this 60 is the smaller element, so you exchange. So 55, then 60, here 66, then 80, and then 77. Okay, now if you carefully observe, once again you get the element less at the left of pivot element, means 66, and all the elements are greater at the right of pivot element, that is 66. So 55, 60 are already in sorted order, so there is no need to sort the elements. Here, this sublist we have to solve again. So 80 is the pivot element. Start from right to left and stop the comparison when you get the small element. So yes, 77 is the smallest element. So we exchange both the elements. So 77 is here, 80 is here. Now the list is 66, 60, and then 55. And now finally your whole array gets sorted. All each subproblems get sorted. See, this is your first sublist. It is sorted 11, 22, 33, 40. Then after that 40, then 44. Then for this sublist, you will get the element as a 55, then 60, 66, 77, 80, 90, and then 99. So finally, you will get the sorted list as, see, here I write all the elements, 11, then 22, okay, then 33, then 40, then this is our pivot element, because this pivot element just break the whole list into the two sublists, 1 and sublist 2. So the 44 is a sorted element. Then after that, we have the second sublist. So this second sublist is sorted again. This problem is break down into again the two subproblems, subproblem 1, subproblem 2. But again, here is the need to sort the elements. So again we solve the problem, and then finally we will get the sorted element as 55, 60, then 66, 77, then 80, then pivot element 90, and already a single element which is occur in a sublist 2, but it is a single element, so no necessity to compare, and it is already sorted in order. So 99. So this is the final output. With this, you know that now the whole problem is divided into the subproblems, and each and every subproblem is solved if the elements are not in the ascending order, or if the elements are not in the sorted order. So that's why it is called as divide and conquer. It is based on divide and conquer technique, because the large problem is divided into the small problem, and again the small problems get solved to get the final sorted array, to get the final sorted list. Now again we see the another example, a small example. Uh, Another one example, yes. Second example is 24, 56, 47, 35, 10, 90, 82, and then 31. Okay, this is the second example. You have given one array with the number of elements, and you have asked that sort the following array into the ascending order. So using the quicksort. So quicksort you know that the quicksort is based on the divide and conquer technique. So first of all, you divide the given problem into the number of sub problems. Okay. Once the problem is divided, then you apply the same steps, means you apply or you solve the each and every sub problem, and this is called as the divide and conquer technique. So here, first of all, you decide the pivot element. Generally, the first element is the pivot element, because in the first pass, the first element is occupied at its final position at the end of pass 1. So in this given example, this 24 is the pivot element. Now we start from the right to left. Okay, right to left. You compare 24 with all the elements starting from right to left. Compare with each element and stop the comparison when you get the element smaller than 24. Okay, 31 is greater element. 82, again it is greater. It is again greater. Yes, the 10 is small than the 24. So here you exchange both the values. So 10 becomes here. Then remaining elements as it is 56, 47, 35, here 24. This you have to check for left to right the large element. 10 is the small element. 56, it is a largest element, greater element than the 24. So now you exchange. So 10, then 24, 47, 35, here 56, 24 is pivot element, then 90, 82, and then 31. Okay, now if you observe, here you get the two different sublist. See, element less than the pivot element. This is a pivot element. And the third list is elements greater than the pivot element. Okay. Now, in the first sublist one, you have only one atom. So there is no necessity to apply the same process again. There is no necessity to conquer the problem, solve the problem. Now we go at the second list. Now we think about the second list. And again, all these elements are greater than the 24, but these elements are unsorted element. So again, you have to apply the steps for second list. 47, 35, 56, 90, 82, and then 31. The first element is the pivot element. Start from right to left and stop when you will get the, here you will get the element small. So 47, 31. Yes, it is small. So just exchange 31, 35, 56, 90, 82, and here 47. Our pivot element is 47. Now you start from left to right and stop when you get the element greater than 47. 31, 35 less. Yes, 56. So just exchange here 47, 90, 82, and this is 56. Pivot element is 47. Now you go from again right to left. So at this right to left, there is no necessity to go from right to left, because you just scan the list from right to left and stop when you get the element less than the 47. But 56 is greater, 82 is also greater, 90 is also greater. So here the 47 is occupied at its final position, and hence you have again get the two different sublist. Sublist 1 pivot element, sublist 2. But sublist 1 is already sorted, 31, 35. This is a pivot element. So now you just solve the second sublist. So 90, 82, and then 56. 90 is the pivot element. Start from right to left. and you just stop when you get the small element. Yes, 56 is the small element. So 56 is here, 82 is here, and then 90. And the whole list is sorted. So 56, 82, 90. And now you combine all the nodes. So the first is the 10. So 10. Then then the second list is this 47, 35. But the pivot element here is a 24. So 10, then here 24. Then we have solved this sublist 2 and we will get the two elements sorted 31, 35. And again the pivot element is 47. And when we solve this sublist 2, then we will get the element in ascending order 56, 82, and then 90, 90. So this is your final sorting order 10, 24, 31, 35, 47, 56, 82, and 90 means finally your whole array get sorted. So the quick sort works like this divide and conquer technique. Now we see that what is the complexity of quick sort. The complexity of quick sort. So in the first pass, you require complexity of quick sort means f of n means the complexity of quick sort means the number of comparisons required to sort the given elements in ascending order. So this is called as complexity, means how many comparisons you require to sort the list. So in the first pass, you require the comparison n. In the second pass, you require the comparison n minus 1 because one element at the first pass, the first element will get its final position in the sorted. So n, then n plus n minus 1, then n minus 2, then dash 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 dash, then you will get 3 comparison, 2 comparison, and at last step only 1 comparison. And mathematically this series is replaced with the formula n into n plus 1 by 2, and if you simplify then you will get n square plus n by 2. The highest exponential order is 2, therefore the complexity is order of n square. But this is the worst case complexity. Worst case complexity because for complexity there are the different types of the complexities: base case complexity, worst case complexity, and average case complexity. Base case complexity means the minimum number of comparisons are required, and for the base case complexity the complexity is different. Base case complexity, the complexity is f of n equal to order of n into log n. This is the best case complexity. And the third is the average case complexity. So the average case complexity means what? It is just the average of both the cases, best case as well as the worst case. In case of worst case, the maximum, it requires the maximum number of comparison, and that's why it is a worst. And in best case, it requires a minimum number of comparison, and average means it requires the average number of comparison. That's why it is called as the average case complexity. And here we stop, and remaining sorting techniques we will see in the next lecture. Thank you very much.